Today we're talking about Chapter 4, Section 1, Quadratic Functions. Now we are pretty familiar with quadratic functions at this point, but there's more to learn. Alrighty, in Chapter 4, we began and we learned how to solve quadratic equations of the form ax squared plus bx plus c is equal to 0, where a is not equal to 0. Right, that's a quadratic equation. So if you recall my little hierarchy I did, I did equation, I did functions, I did one-to-ones, and then I did inverses. Right, so the vocabulary is very precise. So yes, we learned about quadratic equations in 1.4. This time we're going to learn about quadratic functions. Okay, so a function is basically a quadratic equation, obviously, but it's in function form. Okay. A quadratic function is a function that can be written in the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Again, same concept. Every quadratic function has a graph called a parabola. And of course, we know that as something looks like this. Okay, and of course, we know this is a parent function. The parent function being the square function. Okay, and of course, that's what that says down there. Alrighty, and if it is a positive x squared, we know that it cups upwards. But if it's a negative x squared, we know that we are taking it from our transformation process. We know that we are reflecting about the x-axis, and so we flip it upside down. So positive x squared up, negative x squared down. This is super simple. And I'm just going to go ahead and even take the graphing work with us. Okay. Now, I'll be honest with you, if it's up to me, I'd give you a test with nothing but these questions, right? So the example reads, without graphing, of course, we have the graph here, but whatever. Without graphing, determine whether the graph of the quadratic function opens up or down. Well, all you have to do is look at this right here. Is it negative? Yes, then it's opening down. That's literally it. Unfortunately, you don't have many of those questions on your homework, and I'll be honest with you, I don't think they're on the final. I'm sorry, but I mean, you might get an easy homework question. All right, so these are the characteristics of a parabola. These characteristics will be what we outline. Or what we go over when we talk about these parabolas. Okay, so each parabola has a. Well, let's see. I know it lists it somewhere. Okay, yeah, we'll list it ourselves right now. Okay, so the vertex of a parabola is going to be the lowest point on a parabola that opens upward, and the highest point on a parabola that opens downward. So struggling there. Right there is the vertex for a parabola opening upward, and right here is the vertex for a parabola opening downward. Very easy to see. Okay. Now the axis of symmetry. The axis of symmetry is the vertical line that goes through the parabola. Okay. The y-intercepts, we know what the y-intercepts are. We know what 3 and 4 are. We know what 3, 4, and 5 are, honestly. So realistically, the only two new things that we're introducing here are the vertex and axis of symmetry, right? The x-intercepts we know are where we cross the x-axis, which is right here, and the y-intercept, which is only going to be 1 because it is a function, is where we cross the y axis, and of course the domain and range. Okay, well, so for the domain. Right. What is the domain of the x squared function? All right, the square function. Well, the domain is negative infinity to positive infinity. Always, every time, it's not even worth talking about. The range, however, is going to be, in this particular example, again, it's going to be from where we exist on the y-axis. So the range is the y-axis. So right here, all the way up to, and we reach up to infinity. Okay, so you just have to be able to look at the graph and see what the range is. Okay, or I mean, realistically, you can actually get it from your vertex, and we'll see that here in a moment. You don't have to actually look at a graph. I don't know why I said that. I mean, you can. That's why I said that, but you don't have to. All right. Okay, I guess this will be good. All right. So in 3.4. We sketch the graph of f of x is equal to -2 times the quantity of x plus 3 squared minus 1 using transformation techniques. Right, it says watch the animation to see how to sketch that function. Okay, we're not going to watch that animation, obviously. Instead, what we're going to do is this is definitely one of those examples where watching the thing helps. But instead, I'm gonna talk us through it and then do an example, because I'm pretty sure that's where we're going to. Okay, all right. So let's first examine this equation. Okay. Well, okay. We'll examine this equation, and then let's look at the same time, and let's actually do it down here. I didn't notice they put it down here. Okay. We're going to examine the equation and look at the vertex. Okay. So in the equation, of course, we've got -2 times x plus 3 quantity squared minus 1. The vertex is -3, 1. Okay. So if we're trying to put some puzzle pieces together here, notice how the vertex, this 3 is coincidentally the same as, well, it's not the same as a 3, but we're using a 3, and this -1 is the same as this -1. Okay. Now the thing is, this can all be coincidence, and yeah, well, you know what? Let's just get to the definition. This could all just be a coincidence, but lucky for you, it is not coincidence. It is super duper easy to figure out what the vertex of a quadratic function is simply by looking at those two numbers. Okay, so looking at this definition, a quadratic function is in vertex form. Okay, so we have our quadratic equation. Okay, our quadratic function. All right, if it's written in vertex form, so this is called vertex form. Okay, go to the previous page. This is vertex form. Okay, that is the vertex form of a quadratic equation. All right. Now, if you have an equation that is written in that form, it is super easy to see where the vertex is. All right. So if we continue to read on, the graph is a parabola with vertex h, k. Okay. So we're not going to use x and y here anymore, because I mean x and y are being used in our vertex form equation already, right? We have the x here, and of course I guess f of x is y, but we're using x and y up already, so we're using hk. Okay, hk is just basically x, y. Similar to how we did that with the center of a circle, we use h and k for center of a circle. We're now using h and k for the vertex of a parabola. Okay. Now notice how it reads hk. So in this particular case, h is the opposite sign of what's in that parentheses. In the parentheses, it's a negative h. In our definition, it's a positive h. So this tells us we're going to have to flip the sign. So all we're doing right now is we're going to flip the sign of that negative h. Okay, so bear with me here. And then k. Okay, so that tells me that we are taking that k value. Okay, so let's do that with what we have here, and I'm going to make the equation just a tad bigger. I'm going to write it over here because it is a little small. Let's write it a tad better too. Okay. So we're looking at this number and this number. All right. What the definition says on the next page says that we take the opposite sign of this. So the opposite sign of positive 3 is going to be negative 3. Okay, and then we take whatever value this is. Okay, and that value is just simply going to be a -1, and that's the vertex. And of course we can see that right here, and it's actually given to us, -3, -1. So that's pretty darn easy, right? I mean, there's not much to that. We had the vertex given to us, basically when it's written in vertex form, and I'm gonna go and keep that there. It's a lot of John Madden, but we're gonna keep that there. Okay, and of course this is what this is telling us. But let's actually focus on the domain and range real quick. I said that the domain is always going to be from -infinity to +infinity. For both, it doesn't matter because I mean that's how the domain behaves on a quadratic function. All right, the range is going to be a little bit different. And earlier, right before I got over to a slide, I said, you know, we look at the graph, and I said, but we don't even have to actually look at the graph to see the range. We just have to you know, remember the vertex, okay? So in this particular case, the range is going to be from k, okay? So k is the y value from k to infinity when we are opening upwards, okay? Makes sense. And then from -infinity to k when we're opening downward. Okay, also makes sense, right? So let's do this. We look over here, we look at the function. We see that this function, right, is a negative. There's a negative in front, so that tells me that it is opening downward. So that tells me my range is going to be from -infinity to this number here, which is going to be -1. Okay, and that's that. I will erase these though. All right, so let's look at the example here. Alrighty, so this reads, given that the quadratic function is in vertex form, address the following. Okay, I feel like there's more than, yeah. Let's actually, we'll put that on the next page. Okay. No, I think we actually have room on this page for some of these. Well, that's, okay, there we go. Okay, so starting with A. What are the coordinates of the vertex? Okay, so I'm just looking at this number here and this number here. Okay, so I'm taking the opposite of what's inside the parentheses. So if it's a -2, I'm going to put a +2. And if it's a -4 for the y coordinate, I'm going to take the -4. That's the vertex. So that easy. Okay. B, does the graph open up or down? Okay. Well, looking at the function, we see we have a negative out front. Okay. So this tells me that we're going to be opening down. C, what is the axis of symmetry? Okay, so let me put C over here. I don't know. So I told you before, the axis of symmetry is the vertical line going straight down the right here, going straight through the vertex. Okay, so the axis of symmetry is going to basically just be the x value. Okay, so that vertical line is created by the value of x equal to h. Okay, so x equal to h. So we're just basically looking at the x value of my my vertex. So if we look at the x value, well, it's 2. Okay, so therefore the axis of symmetry is going to be x is equal to 2. Okay. Why does it point down if the 2 is in if the 2 in the vertex? Okay, because can we just get that away? Okay, I guess I have to show it before it pops out. Okay. All right, so why does it point down? Because we are looking at if we were to expand, and let's actually go ahead and expand that. How about that? Let's not do ifs. So let's go ahead and expand this, okay? So x minus 2 quantity squared turns into x squared, and this will be minus 4x, and then plus 4, okay? That is that entire binomial there expanded. All right, and then we also have the minus 4, but let's not worry about that for right now, okay? Okay, so it would look like this, right? Because we have the negative out front, right? So all I've done so far is I've expanded the binomial and there's a negative in front, okay? Well, if I take this and I distribute that negative sign, I end up with a negative x squared minus 4x, not minus, that's a plus 4x, plus 4x minus 4. Okay, and then this makes this a negative number. So all you have to do is look at the sign basically in front of the parentheses. If it's a negative sign, then we're opening down. If it's a positive sign, then we're opening up. Alrighty. Next up, we need to find the X-Intercept. So how do we find the X-Intercept? So what we have to do is we have to, and this might be D and E. We can probably fit. We're gonna try anyways. I just don't want it to look disgusting. All right. So find the X-Intercepts. So I know that in order to find the X-Intercepts, I must set y equal to 0, right? So in this particular case, obviously you don't see a y, but we do know that f of x and y are interchangeable, right? F of x is a function of x. The y is the function, the output when you plug x in. Okay, so again, they're essentially interchangeable. So I can basically what I can do is I can say 0 is equal to negative x minus 2 quantity squared minus 4. And if I solve for this, looks like I'll have a 4 is equal to a negative x minus 2 quantity squared. And then if I multiply both sides here by a negative number, all right, so I'm gonna just so I can keep everything on this page, I'm going to erase the negative sign on the right side and put it on the left side, right? Because I'm multiplying both sides by a negative number. So by doing that, I end up with this. Okay, so and then what I'm going to do is I'm going to take the square root of both sides. So again, I'm going to just go ahead and erase it, right? So I'm trying to find the x here, right? So I need to take the square root of both sides. So it ends up being, let's see if I can. I'm going to crisscross them, okay? Because I probably like you also like to have the x values on the left side. So I have x minus 2 is equal to plus or minus the square root of a negative 4. Okay. And by doing that, and then I add 2 to both sides, so we're working our way up here now. Okay, so we're going upwards. So I would have x is equal to 2 plus or minus, and the square root of 4i, well, that's just going to be 2i. Okay. So what does this tell us, right? Well, my x-intercepts are at x is equal to plus or minus 2i, and let's actually, I'm gonna go ahead and keep this arithmetic here, and I'll just let's change the color of the arrows, because maybe somebody would enjoy this arithmetic. I was going to erase everything and just put it there for D. We went this way. Oh, let's do here. Then we went up to here, and then we went up to here. Okay. Anyways, can you figure out how to graph x is equal to 2 plus or minus 2i? Well, I don't know about you, but I sure can't, right? Because, well, it's an imaginary number. So what this tells us is that this parabola has no x-intercepts, okay? Which makes sense. And let's try to visualize this real quick before we actually sketch the graph. So let's try to visualize this. We have a quadratic equation. It has a parabola at 2, negative 4. Okay, so let's close our eyes and try to envision. Okay, so we're going to go over 2 on the x-axis and then down 4 on the y-axis. Okay. So by doing that, we have this. We're going to go over 2 and down 4. So my vertex is somewhere around something like right here. Well, hopefully you can see that dot. It's somewhere around here, and then we know that we open downward. Okay, so by opening downward, we see that we cannot touch the x-axis at all. So that actually makes sense, right? Now it is a lot easier, in my opinion, to go ahead and figure out the x-intercepts than to try and think your way through this, because sometimes it gets a little ridiculous. But this one's pretty easy, and we can visualize that, yeah, indeed, there is no x-intercept. Okay, so let's jump to the y-intercept. Right. And probably should have snipped these equations. So we've got y is equal to the negative, so y is equal to negative. And then I'm just going to go ahead and plug in a 0 for x, okay? Because that's what happens when you try to find the y-intercept. You plug 0 in for x. Okay, I think that was it. Minus 2, minus 4. Okay, good. Okay, and then we just have to solve for y, right? So solve for y, we have 0 minus 2. That is going to be negative 2. Negative 2 quantity squared is a positive 4. That positive 4. Okay, so now it's a positive 4 in here. Okay, that positive 4 now has that negative 1 in front of it, so it's going to end up being a negative 4, right? So it's going to be a negative positive 4, which makes it a negative 4. And the negative 4 minus 4 is 8. Okay, so we're going to have the y-intercept at the value 0. I said 8 should be negative 8. Negative 4 minus 4. Negative 8. Okay. Now let's read sketch the graph. Okay, so sketching the graph, it's not going to be too hard, so let's go ahead and put this over here. I'm pretty sure, let's see if they have a nice pretty graph that I can put up afterward. They do. Okay, good. All right. So anyways, so we have our graph here, and we're gonna have to with that y-intercept, we're gonna have to go a little bit small here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's not the best. 4, 5, 6, 7. Okay. Anyway, so let's sketch this graph. All right. Starting from A, we see that we have a vertex at 2, negative 4. Okay. So we're going to go over 2. And down 4. So 1 over 2, 1, 2, 3, 4. So about right here is my vertex. Okay. I know that it opens down, so it's going to look something like this. Okay. So we're going to open downward. Now I'm going to plot my x-intercepts. Well, again, we don't have any x-intercepts. We can forget about that. Lastly, we're going to plot my y-intercepts, which is at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So right here is my y-intercept, and I'm going to go through there and then down this way. Okay, and that's kind of what it looks like. It's just going to have to be the way it is. This is F. And then G, and then G, say the domain and range. This is easy, right? The domain of F, well, that's going to be, again, from negative infinity to positive infinity. All right, that's easy. It's a no-brainer. Now the range of F. Okay. Now again, you can look at this graph, and you can see that we only exist from here down. There's the only place we exist. Okay, and that horizontal line there is at negative 4. Okay, so we know that also to be, and I'll go ahead and do this. We know that negative 4 is also the y value of my vertex. Okay, so since we're opening downward, and of course we can see it on our graph, we know that my domain is going to be from negative infinity to negative 4. And honestly, we actually include negative 4. Sorry about that. Okay, so we actually include negative 4. And that is my range. Okay, so we get the domain and range and all that good stuff. Right. So hopefully that was I think it's pretty easy work. One moment. All right. Okay, now we got now we have something that's not as fun. Okay, so from the top, we can see from example 2 that if a quadratic function is in the vertex form, it is fairly straightforward to determine its graph. It is very straightforward, right? That was super duper easy. Therefore, to graph a quadratic function of the form ax squared plus bx plus c, we convert it to vertex form, okay? So, unfortunately, looking at this particular function, it's not that easy to tell what the vertex is it? Right? I mean, there is no, you can't just look at it and tell what the vertex is. I do have good news though. All right, good news and bad news, I guess. My wife always likes to hear the bad news first because the good news cleans it up. So here's the bad news. The bad news is we're gonna have to do the completing the square thing that we've done, a couple times before, which I'm pretty sure none of you liked. That's the bad news. The good news is I'm teaching you this so you know, because realistically, after I teach you this, we're gonna find a very easy way to find the vertex instead of doing the complete the square. So let's start with the bad news now. So let's go ahead and do this. Let's rewrite this as f of x. Actually, let's put the vertex form above it. Okay, so the vertex form here in yellow is going to be x minus h quantity squared plus k. Okay, so this is our vertex form. Well, most of it, because I forgot the a. There we go. Because this is our vertex form. So we need to figure out a way to change this into this. And we have to complete the square. Okay, so let's write the equation beneath it. Okay. So how can I figure out how to convert what's in the white to what's in the yellow? Again, like I said, it's going to be completing the square. So what I'm going to have to do here is I know that when I complete the square, whenever we did the complete the square process, excuse me, the value in front of the x squared rather, the value in front of the x squared must be 1. Okay, in this particular case it is 2. All right, but luckily the fine folks over at Pearson made sure that these two numbers are easily divisible by 2. So what I'm going to do is I'm going to factor a 2 out only from the first two terms. Okay, so only from the first two terms, I'm not factoring that. I'm allowed to do that. It's okay, right? I'm just factoring from the first two. We're usually in the process of factoring out of all the terms, right? But in this case, we're just going to do the first two and be done with it. Okay. All right. So we have this part now. So next thing I need to do is I need to take this. I need this square right here to be up there. Okay. So how do I do that? Well, what I need to do is I need to complete the square for what is inside here. Okay. And I actually wrote that wrong. Good job, Sherman. It's supposed to be 2x. Okay, so let's try that again. All right, so I need to fix this too. That's all right. Okay, so what I need to do is I need to complete the square there. Okay, so let's do our algorithm that we have become familiar with. So let me actually underline this in yellow. All right, to show that that's what I'm doing over here. And let's we'll just do this over here in yellow. So 0. My 0th step, again, is always just my formula. My first step, what I'm going to do is I'm going to substitute the b value in, so that's why I'm leaving that blank up top. my second step, I'm going to do the division by 2, so I'm going to leave the entire thing empty. And step 3, I'm going to square everything, okay? So what is my value of b here? Well, it's a negative 2. Okay, what's negative 2 divided by 2? Well, that's going to be a negative 1, and then negative 1 quantity squared is a 1. Okay, so if you recall, whenever we did this, completing the square process, we know that we can rewrite this now as, you can see where my elbow touched down there. We can see it's x squared minus 2x, and then it's going to be plus 1. Okay, and we'll go ahead and put plus 1 there to show that. Ooh, okay, now let's do this. Let's change this color, this negative 1. We're going to change that to a blue. And then the 3 we're going to change to a red. Okay, and of course you're going to see why here in a moment. You probably already know why because you've done this before. Okay, so it was plus 1. Oop, thought I clicked red. And then minus 3. Okay. Well, by doing the process of completing the square, I know now that what is in that parentheses here is going to be not x squared minus 2x plus 1, but it can just be x and then minus 1 quantity squared minus 3. Okay. Now this is not the end of it because there's one important step that we forgot, but I want to drive this point home first before we got there. Okay. But let's actually, oh yeah, what I was going to say was we can actually skip this step. Okay, just like last time, we actually skip that step and go straight down to this step if we wanted to. Okay, but for right now, let's focus on this step. Okay. All right, right here on this step, what did I do? Well, I added 1 to the equation. I changed the entire equation. I added 1 to that equation. Okay, that's not good. I should not have added 1 to the equation and left it alone. Okay, because I made it unbalanced. All right. So up to this point, we know that we've seen, you know, x minus 3 is equal to, you know, like x squared plus 4. Up to this point, we've had equations like this, and then what we did to one side, we did to the other. So if we added 3 to this side, then we add 3 to this side. Of course, these 3's cancel. You know, we've done things like that. What we did to one side, we did to the other. Okay, we did that because equations must be balanced out. You cannot change the value of one side without changing the value of the other. Okay, in this particular case, there is no other side, is there? There is no other side because this is just simply the function. It's not equal to anything. That is just simply the definition of the function. Okay, so what we're going to have to do is be a little clever here. Since we added 1 inside here, okay, we have to ask ourselves, okay, so if we added 1 to one side, and I can't, you know, subtract 1 from the other side, how can I balance this out? Okay, and before we get to this, let's say that well, heck, we'll just have a very simple equation. The equation is going to be my age. Oh my goodness, that's not how old I am. Oh man, 2 years have flown by. We're going to do my age. Okay. Now, if I added 2 to my age, okay, that changes my age. I'm not actually 36, right? So instead, what I'm going to do is, so if I add 2 to this function, then I can also subtract 2. All right, so that's a clever way to do the balancing when you can't balance both sides here, right? So now this is still a function of my age. My age is 34. If I add 2 to it, I must also subtract 2, and I'm still 34. So that's good. So that's what we're doing here. Okay. So since we're adding 1, we're actually not even technically adding 1, though, right? How much are we adding? Well, it looks like 1, okay, but if you recall, we just simply added 1 to complete this square here. Well, I guess it'd be complete this square here. Okay, we added 1 to complete that square. All right, well, if we distribute this 2 through, how much are we technically adding? We're technically adding 2. Okay, so since we're technically adding 2 to the equation, then what I'm going to have to do is I'm going to have to actually subtract 2. and then subtract 2. All right, so I know it's a little confusing. Like I said, in this particular class, I guess, realistically, this will be the only time you see it, okay? Because like I said, there's going to be an easier way to do things after I do this, but I do want to show you, and obviously the editors want to show you as well. But you just have to do a little bit of thinking there, thinking that you're probably not, wanting to, but it's fun if you make it a game. But anyways, we're actually technically adding 2, so we're going to subtract 2. And then we can polish this off. Like this. Okay. So now we can officially say that the vertex is located at +1 and -5. Okay. Again, the opposite of those signs. So we officially figured out the vertex. Okay. And now let's go to the other parts of the problem. Oh, it says A through G is an example 2. Okay, so example 2, well, let's go ahead and snip that. A through G. Okay, so B is does it open up or down, so I'm not even going to snip that, but I'll snip this. New page. Okay, so let's go ahead and just do B. So we did A, we got our vertex. B we're going to ask ourselves, does it open up or down? Now you can look at this function in either case. Okay, we can look at it in vertex form. Okay, well in vertex form we see that this number out front, okay, is positive, so we're opening up. Or we could look at the original equation, okay, and we can see that, well, that's that's a positive 2x squared, so it's opening up. So in either case we are going to be opening upward. Okay, so now C, write what is the equation of the axis of symmetry? And again, the axis of symmetry is just going to be where we go down the x-axis of my vertex. I'm sorry, we make a we make a line, a vertical line is what I would say, vertical line at my x. So my x is equal to 1, so that's what my axis of symmetry is. It's just simply going to be x is equal to 1. Okay. D, find the x-intercepts, and E, find the y-intercepts. Let's see, can we do this easier? Okay, so we could do it in one of 2 ways. We know early on that when we found the x-intercepts of a function like this, all we did was, we did 0 is equal to 2x squared minus 4x minus 3. We did the quadratic equation on that, and then we were done. We moved on. Okay, and that was the x-intercepts. We could do it that way, or we could do it this way. We could take this equation and solve for 0 as well. Okay, so it doesn't matter which equation you do it in. It's just that you're going to get the same solution either way. For me personally, I would probably just take my original equation and do the quadratic formula. Okay, so I'll do the quadratic formula there, and that's it. Now let's actually go ahead and do the quadratic formula. So okay, so it is negative b, so it's going to be we're going to put it right here because it's on this page. So it's going to be a little cramped, I'm sure, but let's fix this. So negative b, so negative 4 plus or minus the square root of b squared, so negative 4 squared minus 4 times a, which is 2, times c, which is a negative 3. Okay, there we go. All over 2a, so 2 times 2. Now I do this arithmetic. Negative 4 is a positive 4, plus or minus, we'll do the entire square root here. So negative 4 squared is 16. And then a negative 4 times a positive 2 is a negative 8. Negative 8 times a negative 3 is a positive 24. Okay, so that's going to be not fun. That's fun. And then all over 4. Okay, so that's going to be 4 plus or minus the square root of 40. So keep that in mind. 4 plus or minus the square root of 40. All over 4. And I'm just going to go ahead and put 4 plus or minus square root of 40 in my phone, because there really is no point in reducing it at this point, right? Because we're not trying to reduce, we're just trying to find x-intercepts. So what is the square root of 40? Okay, so 4 plus that. All right, so one of my x-intercepts is going to be 2.58. Let's just go ahead and put it in where it's supposed to be. Okay, so one of my x-intercepts is at x is equal to 2.58, and then the other x-intercept is going to be at, probably shouldn't put equal sign there, I should probably do little squiggles, okay, approximately, right, approximately 2.58, and then the other one is going to be approximately, that was plus, so we change that to a minus, negative 0.58. Whew, that's my x-intercepts, pretty easy, okay. I mean, once you just have to do the quadratic formula, right? My y-intercepts. Oh, this is gonna be super duper easy. All right, check this out. We know that, we're looking here. In order to find the y-intercept, I set x equal to 0. So that goes boom, boom. Y-intercept is simply -3. Easy peasy. Y is equal to -3. Okay, and then f is reads to sketch the graph. So let's go ahead and do that. Make it a little bit bigger. Alright, so what's my vertex again? It was oh gosh. Okay, I can make it a tad bigger. So let's go over here to 1, 2, 3, 4, 5, 6, 7, 8. Okay. So my vertex, again, was at 1, -5. So I'm going to go over one of the x-axis and down 5. So 1, 2, 3, 4, 5, right here, about, okay. We know that we open upward, so we're going to be, going up like this. Okay. Next, my x-intercepts were at 2.58, so about 2.5, so about right here. Oh, this is going to be ridiculous. Okay, this is definitely one that I snipped the actual pretty graph. The other one is about -0.5, so it's going to be about right here-ish. And instead of making a dot, let's go ahead and just make a vertical line, kind of vertical, I guess, like this. Okay, and my y-intercept is right here at -3. Okay, right here at y equals -3, and then of course from here we can, it should be abundantly easy to see. We're going to just basically connect these lines, right? So let's actually change the color of the parabola and keep what lines I had. I don't know if this helps at all. It probably doesn't. All right, but my red lines are basically my markers, what I put on the graph, right? Again, my parabola, I'm opening upward. My x-intercepts are at 2.5 and -0.5, and then my y-intercept is at -3, and then I just connected those lines. And for the sake of just go ahead and getting rid of that abomination, let's go ahead and, is this the problem? No, that couldn't have been, okay. Yeah, this is better. I don't remember going back pages. Oh well. Oh no, they don't. Okay. Oh, there. Yeah, there it is. Okay, good. I thought they hid this behind one of those animations. Okay, so this is a better drawing. Mine isn't terrible though, so whatever. I think I do a great job. Okay, so domain and range, again, guys, domain super duper easy. This is so easy. Boom. Okay, now the range, okay? So the range, again, all I have to really do is look at the y value of my vertex, okay? So since I'm opening upward, I'm going to be going from the y value, which is -5, all the way up to infinity. All right, that's the domain and range. I don't remember going back in pages. Oh well. So that's that. And again, like I said, that is a particularly hard one. Particularly long, I guess. Not necessarily hard, tedious, right? And I'm just going to leave that there and move on to this page. Okay. Alrighty, here we go. So the formula for the vertex of a parabola. Now this looks like it is not fun, okay? But it's not bad. It's not that bad. Okay, here's why it's not that bad. Okay, obviously, you know, the first part, you know, it's just standard stuff, right? Given the quadratic function of the form ax squared plus bx plus c is where a is 1 equal to 0, the vertex parabola is. Okay, now this part is the part where you are probably just like, what? Okay. So let's break this down. We know that whenever we graph a point, we graph the points in the form x, y. Okay. We also know that y is basically the function of x, right? So we know that this is basically the exact same thing as x and f of x. Okay. So what this equation is telling us here is that we get the x value, right? Negative b over 2a. That becomes just a simple number. Okay? And then the y value is that we plug that x value in to my function and figure out what that number is. Okay? So let's we'll keep this up here. Go to a new page. Oh no, what did I do? Okay, good. I thought I'd just change pages. Okay, so we're going to keep that there. Can you repeat that again? I honestly don't know what I said. Instead, let me go back and do. Sorry. Let me go back and do example 3 and get the vertex this way. Okay. And obviously the example 4 has it, but I want to show just how much easier it is. Okay. So we're going to do example 3. And we're just going to find the vertex, right? We're not going to deal with all the other stuff. Okay, so what I'm going to do is I'm going to find negative b over 2a. Okay, so real quickly, in this equation, okay, let's break this down super duper simple. A, B, and C. What is my A value? Well, it's a 2. What is my B value? It's a negative 4. What's my C value? A negative 3. Right? That's just taking this equation and breaking it down. You know, again, the ax squared plus bx plus c. I'm breaking this down into ABC. Okay. Well, looking at this formula, all right, my x value of this coordinate is negative b over 2a. That coordinate, of course, is the vertex, right? The vertex is going to be like, you know, well, was it like 1, negative 5 or something like that? I don't remember. But we're going to get the x value by plugging that in, okay? So what is negative b over 2a? So let's go over here. Negative b over 2a. Let's get a little closer, I guess. Negative b over 2a. Okay. Well, negative b, so it's going to be a negative 4, right? Over 2a, so 2 times 2. And so that's going to be negative 4 is a positive 4. Positive 4 over 2 times 2 is 4. It's 4 over 4, which is going to be just going to be 1. Okay, so this tells me right away that the x coordinate is going to be 1. Okay, and oh, I bet what was being asked was maybe this part where I talked about f of x. Okay, so I said the x value is, you know, obviously the x coordinate, right? And in order to get the y coordinate, we have to plug x into the function, and then we get that y value. So that's what we're going to do in this particular example. So okay, so we're going to plug this 1 into this equation. We're going to plug 1 into that equation to get my y value. Okay, so let's write the function here. It's f of x. Actually, we're not going to do f of x, we're going to do f of 1, right? F of 1 That's going to be equal to 2 times, and we're going to just go all out with the color coordinating here, squared minus 4 times 1 minus 3. Okay. Well, what is 1 squared? Well, 1 squared is 1. 2 times 1 is 2. So we have a 2 here. And then we have minus 4 times 1. So minus 4 times 1, that's just going to be 4. So minus 4. And then we have minus 3. So 2 minus 4 minus 3 is going to be equal to a negative 5. So that negative 5 goes up here. And we know that that is indeed the vertex of example 3. Okay. Now, that's so much easier, in my opinion, than doing the complete and square process. It is important to know both, but this was the good news. Okay, is we just plug in those values. We do negative b over 2a, and then we get, and let's actually, we'll point. Okay. Pointing really helps out. But anyways, so that's how we get the vertex of a quadratic equation, and that is not in vertex form. If it's in vertex form, it's super easy to figure out what the vertex is. If it's not in vertex form, it's not as easy, is it? Okay. Let's see. And I mean, I basically did an example like 4 just then. All right. Oh, this is actually pretty good. I'm pretty sure this is what we end on. Yep. Okay. So this is one of those problems where I said, you know, hey, I enjoy the process of thinking more than the process of mindless computation, and this is definitely one of them. Let's see. How can I? Oh. We do use the graph. Sorry. Okay, so it's actually not as much analyzing as I thought it was going to be. All right. So we'll start with A. Okay. So what is the coefficient? The leading coefficient. Well, I'm sorry. A. A just reads, is the leading coefficient positive or negative? Okay. Well, looking at this parabola, we are clearly opening downward. So therefore, the leading coefficient must be negative. All right. Okay, so now B reads, what is the value of H and what is the value of K? Okay, well, we know that H is going to be, essentially the opposite of my vertex, right? So if my vertex is at negative 1, 4, then my H, well, actually that's not true. The H is negative 1. Sorry, I got ahead of myself. The H is negative 1. When we put it into the equation will be H plus 1. But for right now, the value of H is going to be negative 1. Okay, because H is just basically the X component of my vertex, and K is the Y component of my vertex. And K is equal to 4. All right, what is the value of the leading coefficient of A? Okay, so this is where it gets a little tricky, but it's not abundantly so. Okay, so first of all, let's go ahead and write, and I'm going to put formulas in yellow. So let's go ahead and write x minus h squared plus k. Okay, so this is the vertex form of my equation. We're trying to figure out what the value of the leading coefficient a is. Okay, now, I mean, before I probably wrote this, you might think, oh, well, how in the world I do that? But hopefully now that I wrote this, it's a little easier. Okay, so let's examine why. Looking at this equation, we have 1, 2, 3 unknowns. Okay, that's not true. That's not true yet. Let's do this, and let's go ahead and plug those values in real fast. A, and then h was negative 1, so it's going to be x minus a negative 1, so it's going to be x plus 1. 20 squared, and then plus 4. Okay. All right. Now this is a lot better. And let's actually go down here and make this equation, put the equation together rather. Okay. Excuse me. So I got ahead of myself. If we look at this, we have two unknowns, or I'm sorry, one unknown. We don't know what the value of a is, but we do know what the value of x and what's over here. Well, that's y. Okay. Well, how do we know what the value of y is? Well, we don't necessarily, not necessarily that we don't know the value of y, or how can I say this? Oh, okay, this is better. We're just going to plug in a point that is on the graph, okay? And so we know on this graph that we have the vertex at -1, 4, okay? And it gives us the y coordinate here, okay? I'm sorry, the y-intercept here, okay? So what we're going to do is we're going to plug in, and it looks like we're going to plug in a 0 for x and a 3 for my y. So this is actually, let's see, we'll snip this. That's a bad snip. It's not any better. Let's see. Oh, that's not too bad. Okay. What did I say we were given? 0 and 3. Okay. So we were given. Oh no. Oh gosh, I did that thing again. We were given that the point 0, 3 is on my. Oh no, what did I do wrong? Did I delete something big? Shoot. I think I might have deleted. Is there an undo button? Nope, doesn't look like one. Okay. If you have made it this far, good job. So what I'm gonna have to do is I'm gonna have to re-put this over here because this is the page I deleted. That kind of sucked. Okay. We said that the leading coefficient, it was negative because we're going down. We did the values of h and k. So let's actually go ahead and do that. Negative the value of h and k. So h was -1, k was 4. Okay, so now we're trying to find the leading coefficient, or the value of the leading coefficient a. So this is the equation we have. We have our vertex, which is placed here, and we have to figure out what a is. So in order to find out what a is, we need to plug in x and y, which is given to us as 0 and 3. Okay, so what this means is the f of x over here is going to be equal to 3. So we're going to say 3 is equal to a, and then my x value was 0 plus 1, 20 squared plus 4. Okay, so all I did here was I plugged in 0 for x and 3 for y, right? 0 here's the x, and here is the y. And again, f of x is y. It's a little disguised, right? But we know that as y. So I plug those points in, and then I just have to solve for a, right? So by doing so, well, what is 1 squared? Well, that's just going to be 1. So I've got 3 is equal to a times 1 is just simply a plus 4. And then, of course, if we subtract 4 from both sides, we've got a is equal to a -1. Okay. So now my equation. All right. Let's see. They just want a? Yeah, they just want the leading coefficient a. Okay. So the leading coefficient a is going to be -1. All right. And D wants us to write the entire thing in the vertex form. So what this becomes is f of x is equal to, and -1, well, that's just going to be negative, right? And then I just rewrite what I have already. Okay, so that's easy. Couldn't you have just taken the -1 the whole time? Couldn't you have just taken the negative 1 the whole time? I don't know what you mean. Okay, so I think I know what you're asking. Okay, so early on we said that the leading coefficient, are we basing that off of the a, because we knew that it was negative? Is that what you're basing your question on? Okay, so we know that it's negative, okay, but we didn't know that it was negative 1. It could have been a negative 4, okay? That's why I had to figure out what the value of a was. It just so happens that in this particular case, a was negative 1, which makes it look, like, it's just negative, right? We said it was negative, and therefore it's negative. But it could have been like a negative 4, negative 2. It could have been negative anything. Just the fact that it's negative. Did that help? Okay. Alrighty. And then E, write the equation of the function in the form. Okay, so now we're going to write it in our quadratic form, right? Our normal quadratic form. So all we have to do basically is just take this and just expand it. All we got to do is just simply expand it. Okay, so let's do some expansion here. So we've got, oh, by the way, when you expand this and you have a negative here, make sure to keep that negative there. Okay, it's very, very important. But anyways, x plus 2 quantity squared is x squared, and then plus 2x plus 1 plus 4. We distribute that negative through now, so we've got a negative x squared minus 2x minus 1, and then we have the plus 4. Okay, and then lastly, we're going to combine that negative 1 and plus 4, so we've got negative x squared minus 2x, and then plus 3. Okay, and that was that. And I believe that was it. A, B, C, D, we're good. Okay, so sorry about that little hiccup where I deleted an actual important page. That's actually the first time I've ever done that, but oh well. Anyways, that concludes today's lecture.